In this video, we're going to continue with our loan analysis. We're going to calculate total number of interest payments, total of our actual payments that we put against principal, and then we're just going to break that out over 1 year. So this particular example, the loan amount is $250,000. The interest rate is 6.65%, 3 years, 4 payments a year. So you want to pay specific carefulness there. And then we have our quarterly payment. This is not calculated correctly. I think with the MyLab downloading the various values, this is actually supposed to be a little higher. So we'll just have a little review of actually doing the payment. So we'll do equal PMT. We have our rate, which is the B7 divided by the number of payments per year, which is B9, comma, and then we want to know the number of payments, which is really 12 quarterly payments. So we will type in B8 times B9, comma, and then you can see it's down here. And then we know that the present value will be a negative because this is a loan, so it's out of our account. And then we will select B6 and we'll hit, there's no future value, and we're going to make it at the end of the period. So again, if your assignment says the beginning of the period, then you need to add the 1 at the very end. Otherwise, you can just leave it as default, which is at the end of the period. So we'll hit enter. And before it was something like $18,000. Now it's $23,867. So I think they put these numbers here just, I don't know why they do that. Okay, so what we want to do is we want to calculate the total cumulative interest payment. So over the course of the loan, which is 12 quarters, 3 years, we want to see how much interest was paid. And there is a function, so type in equal. This function requires that the negative be put outside along with the function name. So I'll do minus, and then this is CUMIPMT, so the I is for interest payments. So I'll accept that. So there are some various arguments here that we need to be careful with. We have the rate. So again, we do the periodic rate, the number of total periods, again, the number of periods, present value. This will enter positive because both of these functions that we're going to use for both of these, they don't accept the negative being put inside. I think it's an older function. And then we have the starting period and the ending period. So here we're going to do started at period 1 and end at period 12. So if you had a loan that was, let's say, 60 periods, and you were interested in the second year, that would be 13 plus 12 is 25. But here we want to know the amount of interest paid throughout the loan. So you can pick out periods. If you were just interested in how much interest will you pay at the 12th period, then the starting period is 12 and the ending period is 12. So they can be the same. Okay, so the rate will be, as we're familiar with, if you haven't caught on by now, it's B7 divided by B9. So this is telling us the periodic interest rate. So it's going to take the 8.65 and divide by the 4, comma. Now we want to know the number of periods. So remember, the NPER is the total number of periods, and that will be B8 times B9, comma. Now the present value is going to be B6. We leave that positive when using these two cumulative functions. Notice that the start period and the end period, these are required, as are actually all of these arguments are required. So we want to know the first period through the 12th period. And then even though in the other functions we've talked about, the end of period was always assumed as the default, but you do physically have to enter this. You have to enter the 0 at the end. And then we can close our parenthesis. And hopefully, if we did this right, there we go, we have $36,517. So over the course of these 3 years, these 12 payments, you would have paid that much in interest. So the kicker here, let me just open and edit this, are these last 3 arguments. So the The 1 that I put here, that's the start period. The 12 is the end period. And the 0 says, hey, the interest is calculated at the end of the period. It is not optional. If you leave it off, you'll get an error. So let's do that again. But this time, I want to know what my total payments were, as in principal. Not the total number of payments. We could just take this and multiply by 4 times 3, and we'd find out what our total payments were. So here, we're going to do equal ICUM, and this time it's going to be PRINC for total amount paid to principal. So when you make a payment, that's $23,876, a portion of it goes to interest every period, and a portion of it goes to principal every period. And as long as you pay these on time, every period, the interest should go down, maybe a lot or a little, and the principal paid should go up a little or a lot, depending on what went down for the interest. Everything else is the same. So the rate is B7 divided by B9, comma. The number of payments is B8, which is 3 years, times B9. Now, if you're doing a lot of this, there would be nothing wrong with adding another cell that calculates the total number of payments, or another cell that calculates the periodic interest rate. It maybe makes your formulas a little easier to work with. Okay, so we'll go to the next one, which is present value. We had to put the negative on the outside, so we don't have to worry about the negative on the inside. So we'll just choose B6, comma. The start period is going to be from the first, comma, to the end, which will be the 12th period, comma, and again, we're doing 0. So remember, we think of this, when I first looked at this, oh, it's 12 years. No, it's not 12 years, it's 12 payments for 3 years. You just group these by 4. So we hit enter. The total amount that we have paid is the $250,000, which makes sense. It should be what we have borrowed in order to satisfy the loan. Okay, well, we can use the same cumulative interest and the cumulative payment to get an idea of how much interest we paid per quarter and how much went to principal per quarter. And if we add those all up, they should be the 36,000 and change and the 250,000. So here it's very important to remember to use your absolutes properly. So we're going to use the same formula, so equal minus CUM, and then this one is the interest payment. So you see the IPMT. Unfortunately, I can't zoom any closer to see that. So that is the interest payment, and we had the principal, which was spelled differently. So the rate will be B7, make it absolute, divide by B9, make it absolute. When I was practicing this before, I forgot that. It's like, why is everything messed up? I didn't make my absolutes. So now we're on the number of periods. So that'll be B8 absolute times B9 absolute, comma, and then we're at the present value. So that'll be B6 absolute, comma. And now the start period and the end period are really the same, so we don't have to worry about absolutes here. So this will basically be A17, comma, A17 for the ending period, comma, and then we want 0 for the end of the period. Maybe we want this for the first year. So then we would do quarter 1 through quarter 4. But here we want to do just the first quarter. And we'll close our parenthesis. Don't forget the 0 for the end. Hit enter. And then we can just copy that down. Now it wasn't required, but if I type in equals sum, I have my toolbar hidden, so I'll just do it the old-fashioned way and do it by the function. And we'll hit enter. And you'll see that those are the same. They should be the same. If they weren't the same, then there's something wrong here. Same thing over here. I'll just put that in while I'm here. And right now it's 0 because I haven't put anything through. So now we want to know at each payment that we made each quarter, how much went to interest. You can see for first quarter, this much went to interest. And then we're going to calculate over here how much go to principal. So we'll use equal minus CUMPR, so we want to know the cumulative principal. So again, remember the function here has the negative outside. So the rate, again, B7 absolute divided by the number of payments per year, which is B9 absolute, comma. The number of periods will be the term of the loan, which is B8 absolute, times the payments per year absolute. If you get some really weird numbers, you haven't made your numbers absolute. The present value is B6, make that absolute. Now we need to know the period. Now before, in these two examples up here, we typed in the first period being 1 and the last period being 12, but here we want to do each period individually. So that's why we actually have to select the actual quarter. So this is the first quarter. So the beginning or the start period and the end period are the same, and 0 to say that we're calculating interest at the end of the period. Okay, and so we just copy that down, and if we scooch down, notice it says 25,000. So what you will notice as the interest goes down, or excuse me, as you make payments, the amount going to interest goes down, the amount that goes to principal goes up. And this is why if you have a very low loan, you'll have less interest going to your payment. If you have a very high interest rate, for the first number of years, you would have more going to interest than principal. So if you're buying a house, even though it may not be very high interest, it might be 5, 6, 7, 8% interest, but it's over 15 years or 30 years. And that would really change the amount of interest going each period. So you'll be paying more interest for the good, 7 years or so, maybe halfway point, and then it flips. So that is doing another loan analysis where we use the commutative function that allowed us to calculate the total amount of interest that we paid over the course of the loan and the total amount of principal we paid over the course of the loan. And obviously these two should match because we paid off the loan. Thank you.